All right, guys, so here's the last 2 pages. It's actually only like 4 problems. Okay, so number 39. Okay, so here they give you, excuse me, f of x, and they want you to find the derivative. So the derivative f prime of x is going to be d dx of the integral of 1 to x squared of the square root of 1 plus t cubed dt. Okay, you guys, this is just a second fundamental theorem. Remember, a derivative and an integral cancel out. The x squared is going to come and take the place of the t. So this is going to be the square root of 1 plus x squared, but the t was getting cubed. And then don't forget to chain rule it. The derivative of x squared is 2x. So simplifying this would be 2x times the square root of 1 plus x to the, that becomes 6. Okay, so that looks like 2x, 1 plus, it looks like a. All right. Okay, this one right here, you guys, it looks like a u sub, but it isn't. If you did a u sub, you would get a d with an x in it, and there's no x to eat it up. So this is just one of those that you have to multiply out. So if you do x squared plus 1 times x squared plus 1, this gives you x to the 4th plus 2x squared plus 1. So if you integrate that, that's going to give you x to the 5 over 5 plus 2x cubed over 3 plus x plus c. So that looks like the answer is E. All right. Okay, 41. So you have the second derivative. Which of the following could be f of x? Hey, does this look familiar? Because this was on your last test. Okay, so if I have f double prime of x is 2x minus cosine x. So if I'm trying to find f of x, I need to break this down. So I need to integrate. So the integral of a double derivative would be a single derivative. The integral of 2x squared, is 2x squared over 2, which is just x squared, minus the integral of cosine is sine. And then I have a plus c. Okay, now the second, if I want to get the actual f, I need to integrate this again. Let me erase this. I didn't mean to put that f in there yet. Okay, so I'm going to integrate this again, maybe with a different color here. Now the integral of a derivative is just the original function. And the integral of x squared is x cubed over 3, minus the integral of sine is negative cosine. The integral of c is cx, and then I'm going to have another constant d. Okay, so let's see what we have here. So I have f of x equals x cubed over 3. A negative times a negative is a positive, and then plus cx plus d. There is no way for me to find c and d because they didn't give me any more information. So it's roughly just going to be based on this. So I have x cubed over 3 plus cosine of x. Okay, it could be this. You might be going, but it's a minus and this says plus. Well, c could be a -1, right? So it could be a. Hey, this one's wrong because that's a negative. This should be a positive. This one right here should be over 3, so this one's wrong. This one is completely wrong. That has a sign that's completely wrong. It has to be a. Okay? Let's look at 42. Okay, so for this one, this looks like integral rules or something like that. So it says from a to b, the integral of f of x is 5. From a to b, the integral of g of x is -1. Which of the following must be true? Okay, so it's saying that there's some function. Maybe you could draw it up like this. And it says from a to b, the area under the curve is 5. Okay, so I don't know, whatever the area under the curve is 5. And then, so this is function f. And then another function from the same a to b, this is g, the area under the curve is -1. Okay, so it's probably has to go below the x-axis at some point. It might be above the x-axis, I don't really know. Okay, now the question is, does f of x have to be bigger than g of x for all x between a and b? Okay, so you guys, what that means is basically, does the function f of x, this is f of x, always have to be above the function g of x? Okay, so does the function g of x have to be below it? So maybe g of x can maybe look something like this. Okay, so that's kind of a weird one. Let's go back to it because we have to look at a whole bunch of different situations for that. But let's see if we can eliminate some of the other ones. So some of the other ones are the I shouldn't have circled these. Sorry, that doesn't mean they're right yet. Okay, the integral from a to b of f of x plus g of x is 4. Well, let's see if that works. I can break it up because it's adding. So the integral from a to b of f of x plus the integral from a to b of g of x, does that have to equal 4? Well, let's see if that works. The integral from a to b of f of x, they told me that was 5, plus the integral from a to b of g of x is -1. 5 plus -1 indeed is 4. So I know this is right for sure. So it can't be a, it can't be c, and it could be the other ones. So let's find out the next one. Now, this one is saying that if you multiply them, you're going to get -5. Hey, there is no rule. I cannot split this up over multiplication, only over addition, right? And only over subtraction. So 3 is not going to work, okay? You guys, which means this has a 3 in it, so that's wrong. This has a 3 in it, so that's wrong. So you guys, kind of by process of elimination, I kind of saw that this was going to be only B. Okay, now let's look at that number 1 and see why that does not have to be true. So look, they're saying that the function f always has to be bigger than the function g. The thing that's wrong with that is, what if it maybe looked like this? Let's say this was your function f, the area under the curve was 5, which is very possible. But then what if your function g just like maybe did something like this and then went below just enough so that like when you subtract them, you get an area of -1, right? It could go above for just like a little bit. It's just too, I don't know what the right word is, but it's too ambiguous to like make sure that that's always going to be true. Okay, so there could be places where that doesn't have to be true. Okay, and then the last one, let's look at this guy. So the graph of f of x is shown. A1 and A2 are positive numbers that represent areas of the shaded regions. In terms of A1 and A2, what is, so I need the integral from -4 to 4 of f of x minus 2 times the integral from -1 to 4 of f of x. Okay, so this means the area under the curve from -4 to 4. So if I'm going from -4 all the way to 4, it's going to be A1, and then because this is below the x-axis, it's going to be minus A2. Then I have -2 times, now this is the integral from -1 to 4. So from -1 to 4, it's just this guy right here. Because it's below the x-axis, that is represented by -A2. Okay, now let's fix that up a little bit. This is really A1 minus A2. Negative times a negative is a positive. So this is going to be A1, and then negative A2 plus 2A2 is 1A2. So it's A1 plus A2, which is D. And I think that's it. All right, we're all done.